Remember, we saw that the slope, or rate of change, can be written as delta y over delta x, which is the change in y over change in x, y2 minus y1 over x2 minus x1. Remember we worked with the line given by the equation 4x plus 2y equals 8, which we wrote in an equivalent way, y equals 4 minus 2x. We found the solutions 1, 2, 2, 0, 3, negative 2, 0, 4, 4, negative 4, 1 half 3, and negative 1, 6, but we noticed that there's infinitely many more. Let's use these solutions we found to calculate the rate of change, starting with finding the rate of change between 1, 2 and 2, 0. Here, the rate of change is 0 minus 2 over 2 minus 1, which is negative 2 over 1, which reduces to negative 2. So between the points 1, 2 and 2, 0, the rate of change is negative 2. How about the rate of change between 4, negative 4 and 0, 4? Here, the rate of change is 4 minus negative 4, our change in y, over 0 minus 4. 4 minus negative 4 is 8, and 0 minus 4 is negative 4, so the rate of change is 8 over negative 4, which again reduces to negative 2. Let's look at another example. What about the rate of change between 0, 4 and 3, negative 2? Here, the rate of change is negative 2 minus 4 over 3 minus 0. Well, negative 2 minus 4 is negative 6, and 3 minus 0 is 3. Again, we have a fraction that reduces to negative 2. Notice, no matter which two solutions we pick, the rate of change between the points is always negative 2. Moreover, negative 2 plays a role in our equation that we solve for y. Let's look at what we just saw and try to understand it in general. Suppose we have an equation for a line that's solved for y. Y equals some number m times x plus b. Let's find the rate of change between two random points, x1, y1 and x2, y2. Before we start computing the rate of change, remember that these points are solutions to the above equation, which means y1 equals m times x1 plus b, and y2 equals m times x2 plus b. So the rate of change, y2 minus y1 over x2 minus x1, can be rewritten as m times x2 plus b, that's our y2, minus m times x1 plus b, which is our y1, all divided by x2 minus x1. But up top, we have b minus b, so it reduces to mx2 minus mx1 over x2 minus x1. But the top we can factor out an m and write it as m times x2 minus x1 over x2 minus x1. But any number divided by itself is just 1, even if it's x2 minus x1. So this reduces to just m. So we can conclude that the rate of change equals m between any two points on a line given by y equals mx plus b. And since it depends on the line, not the chosen points, we will call m the rate of change, or slope, of the line, rather than the rate of change between 2 points.